The final question is about air resistance initially, and there's a bit about power at the end. So now we have Dion joining a skydiving class. So they jumped out the plane and they accelerated while falling for 20 seconds before they opened the parachute. During their fall, there were two forces acting on the skydivers. Using arrows on the diagram below, draw and label the two forces and assume they are accelerating. So the two forces are weight and air resistance, or air drag. And if they're accelerating, then the downwards force of weight must be bigger than the air drag, or the force due to gravity. So we have a downwards force like this. That didn't work. Let's try that again. Like this. We can call that F gravity. And we have an upwards force of air resistance, which needs to be smaller. This is F air resistance. The parachute is then opened, and Dion and his tutor decelerate quickly, reaching a constant speed of 6 meters per second at a height of 1,000 meters until they reach the ground. Describe the motion and the forces acting on Dion and the tutor for the following parts of the jump. Okay, so the first one is 10 seconds after leaving the plane. So they are accelerating. So we wanted the motion and the forces. So to be brief, we can say that they are accelerating. The weight or gravity force, weight force is bigger than air resistance force. Forces are unbalanced. Okay. In the second one, when the parachute opens, well, then the air resistance is suddenly going to become much bigger than the weight force, because the parachute opens, so the air resistance suddenly increases, the weight force stays the same, and that's going to cause them to decelerate. So they will decelerate. Air resistance is now much bigger than the weight force. Forces are unbalanced. And because it's the upwards force that's bigger, and they're moving downwards, that means that they will decelerate. Okay, at a height of 500 meters, remember in the question it said that after reaching 1,000 meters, they then continued at a constant speed until they reached the ground. Constant speed of 6 meters per second, it said. So at a height of 500 meters, they're moving at a constant speed. They are moving at a constant speed of 6 meters per second. Weight force and air resistance force are now equal. And opposite. So forces are balanced. Okay. And then this final question about power. At the end of the jump, Dion helped to load the parachute and other gear into the trailer, and they pulled it back to the storage shed. They had to pull the trailer 400 meters along the road with a force of 350 newtons. and it took them 3 minutes to get it into the shed. Calculate the combined power output required to move the trailer. Okay, power is equal to work done over time taken. And work is equal to force times distance. It's the force applied times the distance moved in the direction of the force. So we first need to work out the work. So the work is going to be equal to the force, which is 350, times the distance moved, which was 400. We can use our calculator to do that. That's 350 times 400, 140,000. Work is measured in joules. And then we can work out the power, because we have 140,000 joules divided by the time taken, which we were given. It took 3 minutes, so that's 3 times 60 seconds. 3 times 60 is 180. So the correct answer here is 140,000 divided by 180, which is equal to 778, rounded. 778, and power is measured in either joules per second, because we've divided a value in joules by a value in seconds, but a joule per second has a special name. It is a watt. Cool, so that's the last question in the test. If there were particular parts of this test that you found hard, then in your little ESA study guide you should be able to find a chapter that applies specifically to that type of question. And so I recommend that you go to the book and you work through that section if there were bits that you found strange or difficult.